Determine all intervals of increasing trend or decreasing trend and determine the coordinates of all maxima, minima, plateaus, or cliffs for the function f of x equals x to the 4/3 plus 32x to the 1/3. First thing to do is find the domain. F of x equals x to the 4/3 plus 32x to the 1/3. Both terms are fractional exponents. The denominator of the fractional exponents is the root for each term. Both of them are an odd number, and an odd root has a domain that is all real numbers. So the domain will be all real numbers or negative infinity to positive infinity. The next thing to do is find all critical numbers. We will take the first derivative, f prime of x equals, each term is a power rule. We can bring down the power, leave the inside alone, subtract 1 from the power, I will call that 3/3, and then multiply by the derivative of the inside. The derivative of x is a 1 for the chain rule. Plus the second term, the 32 comes along, we will bring down the power, multiply it with the 32, subtract 1 from the power, I will call that 3/3, and then multiply by the derivative of the inside to complete the chain rule. The first term, the 4/3 and the 1 can multiply each other to become 4/3, and we have x to the 4 minus 3 1/3 power. In the second term, 32 times 1/3 is 32/3, times a 1 is 32/3, after putting all the constants together. And x to the 1 minus 3 negative 2/3 power. Since the second term has a negative power, we will need to move it around to give it a positive power. The first term is 4. The x to the 1/3 is positive, so it'll be in the numerator, over 3. The second term, there's a 32 in the numerator, and then the x to the negative 2/3 will move to the denominator with the 3 that's already in the denominator to become a positive 2/3 power. As soon as the first derivative has one or more terms that have a denominator, we have to put all terms over a common denominator to make the derivative become a single fraction in order to find critical numbers. The denominator of the first term is a 3, and the second term is a 3 times x to the 2/3, so we need to multiply the first term by x to the 2/3 over itself. So the first term is 4x to the 1/3 over 3. We're going to multiply by x to the 2/3 over itself, a form of 1. So we don't change the value just to look. And that is together with the second term, so that the two terms will have a common denominator. The numerator of the first term, we can multiply these. That will give a 4. And then the matching base of x, we can add the exponents 1/3 plus 2/3, which is 3/3 or first power. So this will become 4x to the first power. The denominator will be 3 times x to the 2/3, and will match the other denominator, so we can now combine the numerators together. So we can add a 32 in the numerator because they are over a common denominator of 3 times x to the 2/3 power. We want to fully factor the first derivative. There is a common factor in the numerator of 4 that will leave behind an x plus 8. The denominator doesn't factor, so we'll leave it as 3 times x to the 2/3 power. We now have the first derivative written as a single fraction. All powers are positive, so we can set the numerator equal to 0 and the denominator equal to 0 and solve for all x's, starting with the numerator. 4 times x plus 8 equals 0. We can divide both sides by 4, and x plus 8 equals 0, and subtract 8 from both sides, so x equals a negative 8. And now working with the denominator, 3 times x to the 2/3 equals 0, we can divide both sides by 3. So x to the 2/3 equals 0, and we can raise both sides to the 3/2 power. 3/2 is the reciprocal of 2/3, and is purposely chosen because when you raise and raise again, you multiply. So 2/3 times 3/2, 2 times 3 is 6, over 3 times 2 is 6, 6 over 6 is a 1, and this will become x to the first power. On the right side, 0 raised to any non-zero power will always equal 0 as long as that power is positive. We now check to see which of these are in the domain. The domain here is all real numbers. -8 is a real number and is in the domain. It's a critical number. X equals 0 is a real number. It's also in the domain. It will also be a critical number. So we have two critical numbers here. We keep them both. We can now draw a domain line, a line representing the domain. The domain has no left end because it starts at -infinity. It has no right end because it goes to positive infinity. We can now put each of the critical numbers on here in order. -8 will come first by being less than 0. Then we have the 0. This will break the domain interval up into 3 separate intervals. We can pick a test value in each of these intervals. The first interval is -infinity to -8. -10 will be in that interval. -8 to 0. -5 will be in that interval, and then 0 to positive infinity, 10 will be in that interval. We can now test the trend of each of these intervals by plugging the test value into the first derivative. We don't care about the value of the first derivative, just whether it is positive or negative. The best place to plug in would be the fully factored version. A couple things about this. The denominator. It's made up of a +3, that's certainly positive, and then an x to the 2/3. Now the denominator of the fractional exponent is the root, and a cubed root can be positive or negative depending on what is inside, whether it itself is a positive or negative. But then the 2 in the numerator of the fractional exponent says that we square that result, and the squaring of the result will always make it positive. So x to the 2/3 is positive because of the 2 in the numerator of the fractional exponent, and the 3 is always positive. That entire denominator is always positive. In the numerator, the +4 is positive, and so none of those affect the sign of the first derivative. Only the x plus 8 will, and we can plug test values into just the x plus 8. Starting with the test value of -10, -10 plus 8 is a negative. We have a negative first derivative. This corresponds to a decreasing trend. Plugging in a -5 into the portion of the first derivative that matters, -5 plus 8 is positive. We have a positive first derivative. This corresponds to an increasing trend. And then plugging in a +10 plus 8 will be a positive first derivative. This corresponds to an increasing trend. So we have a decreasing trend from -infinity to -8. We have an increasing trend from -8 to 0, and then union, because it's happening again, from 0 to positive infinity. These two intervals cannot be put together because the 0 is not included. Critical numbers are always removed from the domain for these intervals of trend. Right at the critical number of -8, we have the trend changing from decreasing to increasing. That means that x equals -8 will be a relative min. So we have a relative minimum with an x-coordinate of -8 and a corresponding y-coordinate that can be found by plugging -8 into the original function. So y will equal f of -8, which will be -8 to the 4/3 power plus 32 times -8 to the 1/3 power. For For the fractional exponents, the denominator is the root. So 4/3 power means cubed root, and then raised to the 4th power. The cubed root of -8 is -2. It'll stay negative because it's an odd root. And then this will be raised to the 4th power. Plus 32 times -8 to the 1/3 power means cubed root of -8, which is -2, and then raised to the 1st power. -2 to the 4th power will be positive because of the even power, and 2 to the 4th is 16. And then we have 32 times a -2 to the 1st power. -2 to the 1st power is just -2. 32 times -2 is -64. And 16 minus 64 is a -48. So we have a corresponding y-coordinate of -48. Right at the critical number of 0, we have a trend increasing and then a trend increasing again. So there was no trend change, but it is a critical number. We want to look and see where this critical number came from. If we look, it came from the denominator of the first derivative. If we have no trend change and it comes from the numerator, that'll make it a plateau. If we have no trend change and it comes from the denominator, that makes it a cliff. So we have a cliff at an x-coordinate of 0, and it will have a corresponding y-coordinate that can be found by plugging the x-coordinate into the original function. So y equals f of 0, which will be 0 to the 4/3 plus 32 times 0 to the 1/3. And 0 raised to any non-zero positive power will be 0. So that'll make this also a 0 here. 32 times 0 is 0, and 0 plus 0 is 0. So the corresponding y-coordinate for the cliff is 0. There's a cliff at the origin. So we have 1 decreasing interval, 2 increasing intervals, a relative min, and a cliff. The cliff that's occurring at the origin is an increasing type of cliff. A cliff is where the tangent line goes vertical. And right at the origin on the graph, it would take a shape something to that effect.